What's up, man?
It was a
So we got the test going, yeah?
yeah. I did it like a few right now, a little while ago. Uh, like I think 4 or 5,
Okay.
and they were simple ones. There was one that we did already. I think it was like I forget her name was Lisa, and they wanted to know the difference between the answer that she thought it was and then the one that she chose.
Mm.
Oh my shit! And then the last one, I'm not sure, but it was they want to know the prime factorization of 18, and I thought it was 2 and 3. They had like 2 to 3 and
Yeah, it would
9.
be 2 and then 3 squared. Because it'd
So
be
that one might have
2
been.
times 3 times 3 would be the. Is this. Oh, okay. Well, this is a different one then, yeah?
Yeah, so I can't go back to that one.
All right.
So that one I must have got wrong and fuck. Well, it's just one. The rest of them I'm pretty sure I got. They're all simple ones.
All right, so prime factorization, that just means all those smaller numbers multiply together to get the 16. So like the 16, the factorization, the prime factorization is the 2, 2, 2. Okay. Using the prime factorization, what is the greatest common factor?
Of both.
So
It's going to be that same thing, right? We do 16 times 1 times 2 times 3.
no, that's the least
Okay.
common multiple. You do that when
That's
you're
the
trying to find the
multiples.
least common multiple. On this one,
It's the division.
the greatest common factor is the most of what is in common. So like they each have a single 2,
Mm-hmm.
but they have more than that in common. They have
3 2s, right?
3 2s in common. So 2 times 2 times 2 is what they both have in common. So it'd be
Oh,
the
okay, and
third
that's
one.
all. Oh, okay.
So when
Yeah,
they
I think when
say
you explained that one yesterday, huh? Because then they had the 2 2. Okay.
right, yeah, this was a similar one except that they had like more threes on a couple of them.
The other one, yeah.
All right. 4 nickels and 88 dimes. To groups where each group has the same number of nickels and same number of dimes. What is the largest number of groups she can have? Okay. In a way, this is, I think,
Like the
asking,
division, right?
what's the largest number of groups where you have the same number of nickels and the same number of dimes? Right, she wants to divide her coins into groups where each group has the same number of nickels and same number of dimes. What is the largest number of groups?
She can have.
Oh, this is weird.
So it's 11.
Yeah, how did you get that?
It doesn't. I just divided both, but I just right when you said that right now, that's going to be the largest group because she can't have 13 of both, right? So she can have 13 of 104 if she kept going with the groups, but because it's 88, that's the limit for both. I guess I don't know if you understand what I'm saying. So she can have 88 groups of 8 groups of 11, right? Pennies or whatever.
Or for
So
the dimes,
11,
yeah,
11
yeah.
groups,
Okay, I got you.
11 groups. I mean 11 groups, yeah, of both, and then the rest of the nickels. I don't know how she's gonna do with them, but that's the most of the same groups she can have. I must be confusing you.
No, I just think she wants to divide her coins into groups where each group has the same number of nickels and the same number of dimes, like all the groups. So if she had 11 groups total, that means she would have. Oh wait, did you do 104 divided by 11?
Yeah.
And you got a whole number? What'd you get?
No, I got 9.45.
So that means
So I What is the largest number of groups she can have?
I think you're right with dividing though. 104. Let's see.
So maybe it's
104
nine, I guess.
divided by 13 gives you 8. Oh, and then 88 divided by 13. No, that doesn't work.
Yeah, that's.
104. I'm seeing if
I
104 divided by those numbers ends up giving you the same number. So 88 divided
has the 88.
104 divided by 4 and 88 divided by 4. No, none of them give you the same number.
So that's the only reason I thought it was 11 was because she can have. So like let's say she has 11 groups of 8, right? Of 80, that'd be 88 dimes.
Yeah.
And then so she makes 11 groups of the out of the nickels with the 8 quantity as well. That's the biggest number she can have of both. I don't know. Yeah, I don't know.
Yeah.
So maybe it's 8. I have no idea. I don't know.
She wants to divide her coins into groups where each group has the same number of nickels and the same number of dimes. Oh, it's not like if you have 8 dimes in a group, you have 8 nickels in a group. It's like if you have 8 dimes in a group and 5 nickels in a group, then in every other group you have to have 8 dimes and 5 nickels. Do you understand what I'm saying? It's a weird.
Yeah, I see now. Yeah, it's a weird one. It got to me.
So like you could have. Well, let's do 104 divided by 13. That means, so if you do 104 divided by 13, that's 8 nickels and in 13 groups. Can you put 88 dimes into 13 groups? That's dividing. 88 divided by 13. No, you can't.
No.
Okay, and then 104 divided by 11. You can't put 104 nickels into 11 different groups evenly, so that doesn't work either. What about 104 divided by 8? That equals 13. So you can have 8 groups of 13 nickels, and 88 divided by 8 is 11. So 8 groups of 11 nickels, and each group would have 11 11 dimes. Each group would have 11 dimes, and each group would have 13 nickels. I think it also works for 4, but it says the largest number. I think the answer is 8 on this one. That's a weird one. It's like, I think what they're getting at is what's the largest number that divides into both of them.
Oh, okay.
And 4 divides into both of them, but 8 also divides into both of them, right? And it's the largest. Yeah. That's.
See, I got it mixed up because I thought what's the large, even, but I guess she has to use all the coins. But no,
yeah.
How many? Yeah. So there you go.
That's a weird one.
I get you with these retarded questions. Mm-hmm.
Least common multiple of 6 and 15. So that means you write out like a couple multiples of 6, being 6 times 1, 6 times 2, 6 times 3, blah, 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 blah. You write out a couple multiples of 15, 15 times 1, 15 times 2, 15 times 3, and you find whatever's in common, but the smallest one. Her work is shown below. Okay, so 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, times 4, yes, times 5, yes, times 6, times 7, times 8, times 9, times 10, okay. 15 times 1, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60. Okay, the least common multiple is 60. Found the least common multiple, 6 times 1, 6 times 2. Oh.
Is it not 30?
It should be 30. That's her error. So which one of those means that?
Oh, okay. Maria listed some values that were not multiples. Maria listed factors of each number instead of multiples. Maria should have multiplied this. Find at least some multiple. I guess she selected the multiple that's not the least common multiple, right?
Yep.
Multiples. But she went all the way up to 60.
Yeah, she went all the way up to 60 when 30 was in common and she didn't see it. Cool. Okay.
So this is the -3, right?
Yeah, so
You can do that one the way you do it.
there's a lot of steps in this one.
Okay. It's going to be a positive though at the end, right? Because it's two negatives, right?
No, because it's an exponent instead of just straight up multiplication.
Okay.
So it's different on this one. Here, let me write it down and then I'll share mine. 3 5 equals 1 over x. So there's two things that we could do. One of them is just look at this negative. So it's like there's a 1 out here, and then there's a 1 on the bottom. So if we take this whole thing and just move it to the bottom,
flip it, right? Okay.
Then this becomes a positive. So it would be 1 in the top from there, and then 1 times -3, but to the +5. And then...
So the only thing that changes is the exponent.
Right. This still stays negative. And then 1 over x. So then we can have, that's the same thing as 1 over -3 to the 5th equals 1 over x. So here, I'm going to look at just this part and type it into the calculator. So -3 times -3 times -3 times negative, like 5 times.
Okay. It's 243 is what I got.
Is it? Yeah.
I just didn't do that. Yeah, I didn't do the negative.
So if we had 3 negative and then the exponent button, which is the x to the y, and then to the 5, now because it's positive, -243. Because that's...
Does it have to be over the 1 though? Or, because there's
it's going to be
an answer with...
Yeah, so it's going to be 1 over -243. So now we're at this step. So we're not done yet. The way that we looked at this before was when you have a fraction equals a fraction, you can cross multiply by doing this. So like 1 times x, that's the same thing as just x. And then -243 times 1, that's just -243. So that's the answer. Do you remember doing this cross multiplying?
Yeah. So it's just a 243.
Yeah, so like you bring it down to make the exponent positive, and then once it's positive, you can make it into just a regular number, but it's still on the bottom because we moved it to the bottom. And then since it's one fraction equals another, then it's cross multiplying. which is
All
in
right, I think we did
order
this one
from.
last time. So I can tell you already it's B, just because we did it yesterday.
Is B.
And or wait up. No, it's actually A. It was a
Oh yeah,
because
yeah,
yeah.
yeah. So the last two on A, the 6 times 10 to the fourth and the 8.1 times 10 to the fourth, since they're both 10 to the fourth, you don't have to worry about that part. You can just compare the 6 to the 8.1, and the 8.1 is bigger. So you already know that. That's in the correct order. And then that -5, that makes you move the decimal to the left
More
5
right.
times more, yeah, than the 2. So yeah, it is A. It is A. So it's a +4 on that one.
Okay, I'll do this one. Positive moves to the right.
Mm-hmm.
So it'd be C, right?
Yeah. Wait, did we skip a bunch?
I think I did, yeah. Well, we'll do this one and
Yeah,
then
we'll
go
do
back.
it. Okay. So factors are smaller than 18. This is the one where you do like that little the tree diagram.
And all these numbers, like the first one, they all can go into 9. I mean to 18, right? But it doesn't mean. Okay.
Yeah, well, so all of them, like, if all of them go into 18, then they're all factors. If there's something that doesn't go into 18, then it shouldn't be on the list. It's not a factor. So like you could just do 18 divided by 1, that works. 18 divided by 2, that works. 18 divided by 3, just in the what is that? 6 times 6. That works. 18 divided by 4, I don't think works. So
Yeah, you're
4,
right. Because
yeah,
it'll be 16.
4 is not a factor. So then it can't be A. So you can just
So
check
then
the rest
it's
of them.
B.
I think so. 6 times 3, 9 times 2, yeah. And then 18 times 1. Yep. You gotta click on 11.
120. This is the.
We just did this one. Oh, wait. Did we do that one? We did do that one, right?
Oh, well, we'll get to it.
Wait,
I
we
thought I
still
did.
gotta
I
do
meant to.
11, right?
No, we did 11, I thought. Yeah, it was the
Oh,
point.
okay. Yeah, yeah.
Composite numbers have. It should have less than 2 factors, right? Well, no, I don't know. You can.
So composite numbers mean that they're not prime, and prime numbers mean you can only divide by 1 and by the number itself. So that means for prime numbers, you have 2 factors. For composite numbers, you can still divide by 1 and you can still divide by the number itself, but by definition, you also can divide by something that's not 1 and itself. So it's more than 2 factors for that one.
Composite.
All right. Okay.
Least to greatest. So I'd say is D, right?
Which one?
The last one.
No. So with the first two on the last one, those are in the correct order because the -8 on that first part of that answer means move the decimal left 8 times, which means you have 0.000000, and then the 9.4. So there's like 7 zeros before you get to a number. And then the next one is only like 6 or 5 zeros before you get to a number. So the first two are in the correct order. The last two are not in the correct order. Because the 7, since the 10 to the third and the 10 to the third, since those are the same, you can just compare directly the 7 and the 2.5, and those aren't in the correct order.
All right, so it'd be it's C then. Be right.
Here, let's just write them out and see what happens. What was that last answer?
It's 9.4 to the -8.
And then
9.25 to the -6.
and then 7 times 10 to the 3. What is it, 2.5?
2.5. Yeah.
So these ones are in the correct order, but just to write it out, the -8 means to make it, so it's already in scientific form, scientific notation form. To make it regular, you would move the decimal to the left because it's negative, and that's what it means. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 1, so there's a decimal. 1, 2, 3, 4, 5, 6, 7. 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Whoops. 7, 9, 4. And then the next one, we only move it 6 times. So 1, 2, 3, 4, 5, 6. 2, 3, 4. That means we have 5 zeros. So 1, 2, 3, 4, 5, 9, 2, 5. So because this has more zeros in front of it, this one is bigger. Like if you were to compare them, if you were to write down, this has 5 zeros. So 1, 2, 3, 4, 5, 9, 2, 5. You can think of this like you can add zeros to the back all day long. Like it doesn't matter if you add them to the back after this decimal point. But if you were to like get rid of this part, the 92,000 whatever, if we lined up all these zeros, that zero would line up there and the zero there. Like this is like 94 if you think about it, and this is like 9,250. So this one is bigger. So that's in the correct order, just because it has less zeros before the numbers show up. So that's in the correct order. For this, it's a positive 3, so that just means this is the same thing as 7.0 times 10 to the 3, and 2.5 times 10 to the 3. The 3 being positive means move the decimal over to the right, 1, 2, 3, so that would be an extra 2 zeros. So this would be 7,000, and this is 1, 2, 3.
Yeah.
And that would be 2,500. So this is not the correct order because 7,000 is bigger than. So these would need to be switched around. So which answer is that?
Okay. What I did then, I went left on both.
Oh, I see. You went left
I
on
see on
the.
my paper. Yeah, even on the positive, or the
Yeah, I
positive
see. I
threes.
see. So I think it would be the first one again. Simon examined the pattern in the table. Okay, so the pattern or the table is correct. Based on the pattern, which power of 10 would have a value there? Try figure this one out, and then let me know if
Okay.
you need me to explain, or I could just check you.
No, no. I'll try to see which answer again. So the answer I got from doing them all, I got the last one with an equal.
The 10 to the sixth.
Yeah.
So the only thing, so 10 to the sixth, that gives you 1 million. But do you see all of the ones on the left side of the column? Those are all negative numbers.
Yes.
So the negative is what makes the bigger number go on bottom. Like you bring it
Oh, you're
down to
right.
the
Yeah, you
bottom.
can bring
So
it down right there.
it would be that first one, 10 to the negative
So I
six.
would have to. Okay, cool. I just did it off my calculator.
Like so,
So
it's
I'd run
right.
the.
Like if you did 10 to the one, that gives you 10, but the 10 is on the bottom, and that's because it's not 10 to the one; it's 10 to the negative one. Uh, if you 10 to the one, just gives you regular 10 on the top. That's why that shows in the top of the little chart thing. But once
Yeah.
it starts getting negative, all the numbers end up on the bottom of the fraction. But that's because of the exponent rule. When the exponent's negative, you can move it down to the bottom before you evaluate it.
Then it becomes positive, right?
Yeah. So it's the first one.
Next time I'll write it down instead of going about it the easy way. But I would have been wrong.
This one, I think you got this one.
It'd be 20, right?
20
Oh, it
is.
could be.
And it's just which one is a factor. So if you divide 100 by 8, that shouldn't work. 100 by 12, that shouldn't work. 100 by 15,
15 should, right?
I don't think it does. Does it?
Oh, no,
I don't think
it's
so.
120.
And 20 works.
Yeah, you're right.
Okay. This one, you change them to exponents. So if it's y, and you rewrite that with an exponent, do you know which one that is?
The A, right?
Yeah. Because it's y to the third, that just means y times
Yeah,
y
three
times
Y's.
y.
Right?
Yeah. And then 4 z's means z to the fourth. Perfect. Okay, so wait, look at the table. You know how it shows 6 to the 1, and that gives
Yeah.
you the value is 6?
Yeah.
Yeah. Well, It's almost the same thing for 6 to the negative 1, except for what do you think is going to be different just from that other problem that we did? Instead of it being 6.
What's going to be? What do you mean? So it's
So,
going to be a -6, right? But
uh,
if it goes,
so on the last problem, when it had like 10 to the 1, it gave you 10 on one side of the table. And then it did 10 to the 0, which gives you 1. And then 10 to the negative 1 gives you 1 over 10. Anytime the exponent is negative,
it has
you
to give
got
you.
something in the bottom of a fraction. So I'm trying to say that like you have 6 to the 1, 6 to the
It's going
positive
to be
1
6, right? And then
is going to be 6. 6 to the negative 1 is just going to be the same thing, the 6,
-36
except for
underneath.
1 on top and 6 on the bottom. 1 over 6. So A should be 1 over 6. And then the B, yeah, 6
Oh,
to the
so A.
positive 2, 6 to the positive 2 gives you 36. If the 2 is
Yeah.
negative, then it should give you 1 over 36. So that's right. The value of A is -6. So the first answer is not right. The second answer, yeah.
Bonus decrease each previous value is divided by 6.
Yeah, that's true too, I think. The exponents increase. 6 is added. No. If the table was extended.
36 times 36.
Well, let's see. So as the exponents decrease, each previous value is divided by 6. So let's see if that's true. Scroll up a little bit. So it's saying as the exponents decrease, so on the left side we have a 3, and then a 2, and then a 1, and then a 0, and then a -1, then a -2. That is decreasing. Okay, so as the exponents decrease, each previous value is divided by 6. If you take the 216 and divide it by 6, what do you get?
36.
36. Okay. And if you take the 36 and divide it by 6, what do you get?
6.
6. If you take the 6 and divide it by 6, what do you get?
1.
Okay. If you take the 1 and divide it by 6, what do you get?
6.
You don't get 6.
So it is. If you do the 1.
1 on top and then divide it by 6,
yeah,
you should get a decimal, right?
Yeah, you get decimal.
Or you can just write it as a fraction, as 1 in the top, and then the division bar, and then 6 in the bottom.
1 over 6.
Yeah, and then so the next, so that one is correct. As the exponents increase, that's not correct. The last one might be correct.
It's correct. But I just multiplied the
Yeah,
6 times
is
36.
yeah 6 to the regular 3, 6 to the positive 3. Is that 216 from up above? Yeah. Okay. Yeah. So then that last one is correct too, because if it's negative, it means put it on the bottom. Move it to the bottom, and then 1 will be on the top. Okay, so each of those, so the factors mean that they all go into those numbers. So the factors of 42 means you could do 42 divided by 1 and get a whole number. 42 divided by 2 and get a whole number. 42 divided by 3, and so on. So if those are correct, then let's see. Yeah, I'm going to check those first.
Okay, I'm checking.
If you were to make a list of the factors, what would you
Yeah.
do?
I'd keep going till. So I mean, I would do what he did, right? But just keep going up, because I got 21 to be a greater factor than 7 that he got.
The greatest common. Oh, so 21 goes into 63. Is that what you're saying?
Yeah, 3 times.
Yeah, I think you're right. So what's his error?
Okay. Well, you did not list all of the 63 factors, which I think that's it. But wait, you found the least common. You found the least common multiple. So the first one, right?
Yeah, it is the first one. Because you found that you could divide 63 by 3 and divide 63 by 21, and he doesn't have those listed for 63.
Yeah. Oh yeah, he doesn't even have the 3.
But the greatest common one would be, yeah, the 21. Cool. Okay, least common multiple. That's the one where you start with 4
And go up.
and it goes up, yeah. So you list out like 5 of them and see if there's
It'd be
any.
20, right? Because if it's the least common multiple for both of them,
I think so, yeah.
there's no way that 10 could go into.
Anything other, yeah,
Yeah.
You can't get the 4 to be a 10 by multiplying it by a whole number, yeah. Which only lists multiples of 18.
And the multiples are uh, adding, right? Freaking multiplying.
Well, it's multiplying and they always get bigger. So the first multiple of 18 is just 18 times 1. And then the next one is 18 times 2, whatever that is. And then 18 times 3, whatever that is. And then 18 times, and then so on.
So like for this one, you would keep going. You would just go freaking. Wait up. Let me try something. So it's definitely not C.
Correct. It's not that one. So you start.
So it's gonna be the last one.
Yeah, it's going to be the last one. Because if you start with.
With that number, right?
What's that?
You start with 18, right? And then you can only go up.
Yeah, so that's the 18 is the 18 times 1, and then 18 times 2 is 36, 18 times 3 is 54, and 18 times 4 is 72. And you could keep going, but it's saying, I mean, the other ones, 27 is not a multiple, and the other ones they look like they're factors, so. Multiples are bigger than the number, and factors are smaller than the number.
So like
We did this one.
Yeah, that was the one where.
They kick you out.
Mm-hmm. It's doing that crap again, I think.
Yeah, it would have let you change the answer to that one.
I know.
And we've already seen it. No, maybe that's why it's freaking out.
You in here? I'm just gonna log out and then see if let's get back.
Okay.
It always does it around this time. It's weird.
Yeah, that is weird.
What days do you go to school? Or are you just doing it online too?
Yeah, it's just
Yeah,
online.
everything's
So
online.
whenever whenever I do it, I just took a test today actually. So for me, like the way that I have to do it, it's they like make you have a webcam.
So you have to be in class.
No, they so I took it here, but they make you record yourself on a webcam, and they make you like show the webcam to like the rest of the room to make sure there's no one in the room, and you're not allowed to talk like during the exam. Um, and then you have to share your computer with them and like, make sure that um, like only certain programs are open so that you can't record anything or like have
Okay.
whatever going on. So um, yeah, it's different, but yeah, I just took a test today. I just do it whenever I can.
Before, when wasn't here, I'd have to go in there and take a test. So if I had to do a test, I'd have to go in the classroom.
Mm-hmm.
But
it's super nice this way.
Well, since they closed everything, I think now they don't care because you can cheat basically.
Right.
I can download like I forget what it's called, but you have to pay. But they make money by people graduating because if nobody doesn't graduate, then what's the program doing?
Right.
They're,
Right.
they're failing, so I don't think they care now.
Which list shows all the factors of 36?
So it's going to be smaller.
Yeah. What I was gonna say, wait a minute. The first two are the same, but they're not the same. There's something different.
The 8.
Yeah.
So then the factors are going to be smaller, obviously, but these are the ones that I divide into.
Yeah.
But it's
Into
not the prime
36.
factor, right?
No. So this one is just all the factors. All of them should be able to go into 36. And then it says list all of them. One is a factor of every single number. So answer C
That
and
one.
answer D don't include one, so they're not correct. So it's either A or B. And you just got to see which one has all of those numbers listed. All of them have to be able to divide 36.
So it's an A.
Yeah.
Because the 8.
Yeah, 36 divided by 8 gives you the decimal, some decimal.
It's one of those ones.
Oh, we did this one, I think. So the 3 over the 5, the 3 over 5 is in parentheses, and then it has the exponent of 3. Because it has parentheses, that means the 3 goes to the 3 over 5. So it should be 3 over 5 times 3 over 5 times 3 over 5. But what he wrote was 3 times 3 times 3, and only the 5 once. It should go both to the 3 on the top and to the 5 on the bottom. So he didn't multiply The denominator. Yeah, it's the second one. Do you understand what I'm saying, or you want me to show you?
Yeah. Because yeah, I remember we did it yesterday. Because if it would like the second once he equals, so it's 2, and then the parentheses 3/5, and then the 3 outside. So he went based off like the second one, or it's not the second one, but it's his next step, 2/3.
Right.
So he put the 3 in the parentheses. So,
Yeah, it should have been. It should have been for both of them. He just put it to the 3 on the top, so it's 333. It should have been 333 on the top and 555 on the bottom because the original, the parentheses were around both the numerator 3 and the denominator 5, so they both should have been 333 and then 555. So this one is just figuring out the first 5 prime numbers. And remember, one is not a prime number.
and what does it mean by the sum? Like of the first 5?
You figure out the first 5 prime numbers, and then sum means add them all together. So like you start out, I would just list out 1, 2, 3, or maybe up to 10. Let's see, 3, 4, 5, 6, 7, 8, 9, 10. 1 I'm crossing out because by the definition of prime numbers, 1 is not a prime number.
Yeah.
And then
also 4, right?
4, yeah, is not a prime number because you can divide it by 2. And for it to be a prime number, the only things you should be able to divide by are itself and 1. So 4 doesn't work because you can divide it by 2, which is not itself, which is not 4, and it's not 1. 5, the only thing you can divide is by 5 and 1, so it's itself and 1. What about 6? Is that a prime number?
No, it's not.
No, because you can divide it by 2 or by 3. Yeah. What about 7?
Same. It's not. I mean, it is a prime number.
It is a prime number. What about 8?
Yeah. And no, because you can divide it by 2 or 4.
You can divide by 2 or by 4, so that's 1, 2, 3, 4. We need one more. What about 9?
You can divide it by 3, right?
Right. So that's not a prime number. What about 10?
No, that one's not.
Nope. You can divide by 2 or by 5. What about 11?
Oh, okay, so it just wants me to figure out the first 5. So
figure out the first 5 and then add them together.
11. I mean, you can divide stuff into it. No, I guess not, right?
11. Can you divide it by? So every number you could divide by 1. Every number you could divide by itself, but can you divide it by a different number?
No.
2, no. 3, no. 4, no. 5, no. 6, no. 7, no. Divide by 8, no. 9, no. Yeah, 11 is a prime number. So that's the first 5 prime numbers. It's 2, 3, 5, 7, and 11. Because there's 5 of them, and you add them all together.
28. That's
correct. Yep. Jamie created the list of factors of 32. Okay, so she or he created the factors. So that's all of those numbers should be able to divide 32.
Okay.
Which number should be removed from this list to make the list accurate?
6.
Let me see. Yep. That's the only one that doesn't divide it.
Yeah, the rest of them are good.
Cool.
Yes, I must have missed that one. I missed the one that I told you about
for the prime thing.
Yeah.
Was it said, what was it? Graphing in the coordinate plane?
Yeah.
Okay, just look at that. I say, let me say some stuff on this, and then maybe you can try it, or we could do it tomorrow.
Yeah.
Graphing in the coordinate plane. Okay.
Same. I'll watch a video here and there. Cause
cool. But
it.
The basic thing, that's what I'm gonna try to cover. The basics.
Cool.
So to graph a point. So let's see if I had, this is called the coordinate plane, where it has tick marks in every direction. Up and down, this is the y-axis. So all of this is the y-axis. It's always up and down. And then the x-axis is always horizontal, left and right. And these are, positive is in like the right side for the x-axis. Negative is the left side for the x-axis. And I'm going to explain what this means, but I'm just going to say it all right now. And then let's say positive is upwards on the y-axis. So all of these are positive, and then negative is downwards. So like this would be positive 1, positive 2, positive 3, positive 4, positive 5, and so on. Negative 1, negative 2, negative 3, negative 4, and forever. That way, positive 1, 2, 3, 4, 5, and then negative 1, negative 2, negative 3, negative 4, and so on that way. So, basic graphing is plotting a point where the first number, so these are going to be numbers. They could be positive or negative. The first number is the x, so you do it on the x-axis. The second number is the y. So if I had 2, 3, both of them are positive. So the x, that's the 2. So that means I start here. And I go 1, 2. I don't draw a point yet because I have to finish with my y coordinate. And that's positive 3, so that means I go up 3. So from here, I go 1, 2, 3, and then that's my point. So I would actually get rid of that and that. So this is 2, 3. Over 2 on the x, that's that part, and then up 3 on the y. That's 2, 3, that part. If it was negative 2, 3, you always start out at the middle. This is called the origin. The negative 2 is for the x because it's in the first spot. The first spot is always for the x. So negative 2 means you go this way, 1, 2, negative. But we're not done yet. We got to finish with the y coordinate. That's positive, so 1, 2, 3. So this one is negative 2, 3. The negative means you went backwards on the negative part of the x-axis.
Same with if it was a negative 2 and negative 3, I would go to the negative 2 and then go down.
Yeah, 3. So if it was negative 2, negative 3, you'd still start here, 1, 2, and then 1, 2, 3. So that would be negative 2.
Negative. And you think what they're going to ask me are like these simple ones? Or they'll get a little...
I feel like they're gonna ask you to do some questions that are like a little bit tricky, but like one other thing is that this is called the first quadrant. They use Roman numerals. Uh, so like up here is the first quadrant. Here is the second quadrant. Um, this would be the third quadrant, and then the fourth quadrant. So just 1, 2, 3, 4. Sometimes they might say like, if I have negative, or maybe like positive A and negative B, where this is a positive number and this is a negative number, which quadrant would I end up in? And the way you think about that is, well, if this is positive, then you're going to eventually start going to the right, some number. Right. If this is negative, then from here, you're going to go down some number, which puts you into quadrant 4. So they might have some questions like that.
Cool.
I think if it's graphing in the coordinate plane, that this is where you start out. So these are just the basic stuff. Later on, they would have you do lines, like drawing lines, but I'm not sure they would do that yet. But that's just the basic idea. So maybe you can see where that takes you.
I'll give it a shot, and if it's a little weird, then I'll just stop it.
All right, sounds good. So then tomorrow we can pick up?
Yeah. If you have time,
yeah, sounds good.
All right, bro. Good night.
All right, night, man.